This video covers writing equations of lines, so we'll learn, given different sets of information, how to write an equation of a line. The first example we'll talk about is writing an equation given a graph. The first piece of information we would want to remember is that we are going to be writing these equations in slope-intercept form, which is y equals mx plus b. M will be our slope, and when we find slope given a graph, we do rise over run, so we're going to count up and down first, and then left and right. Our b value is our y-intercept. Our y-intercept can be found by looking at the graph and determining where it crosses the y-axis. In our first example, if we start counting slope, we want to start at the leftmost point, so that would be this point here. I would go down 1, 2, 3, 4, 5, 6. So down means negative, so negative 6. Then I go to the right 2, which would be positive. Negative 6 divided by 2 is really negative 3. So I have a slope of negative 3 for my first graph. Then I need to determine my y-intercept, which remember is found by looking at where the line crosses the y-axis, which is this point here, which is 0, 6. So my slope is negative 3. My b value is 6. When I write my equation, it's y equals negative 3x plus 6. For my second example, again, I'm going to start by finding my slope. I'll start with the leftmost point here. I count up 2, which is positive. To the right, 1, 2, 3, 4, which is also positive. 2 over 4 simplifies to 1/2, so my slope is 1/2. When I start to find the y-intercept, it's wherever this line crosses the y-axis, which is 0, negative 2, which makes my b value negative 2. So then when I write my equation, I have y equals 1/2 x minus 2. The next information we're given is a slope and a y-intercept. So again, just recall, we're going to be writing these in slope-intercept form. So that's y equals mx plus b. Our slope is m, b is the y-intercept. So for our first example, write the equation of a line with a slope of 1/2, so that's m, and a y-intercept of negative 15, that's b. So I would write out y equals 1/2 x minus 15. The second example says write the equation of a line with a slope of 0 and a y-intercept of 4. So that'd be y equals 0x plus 4. Now, we don't really need to write out 0x, so it's best to simplify this to just be y equals 4. Recall that this would actually be a horizontal line when graphed. And so if I drew a graph, it would really just look like this. So anytime we have 0 slope, our graph will be a horizontal line, and our equation will be y equals a number. For the next set of examples, we're given slope and a point. So it says write the equation of a line that passes through the point negative 3, 6 and has a slope of negative 1. So this time I'm given a point which gives me x and y, and slope which gives me m. So for step 1, it says plug in x, y, and m. So my equation is y equals mx plus b. If I plug in y, x, and m, I have 6 equals negative 1 times negative 3 plus b. When I simplify, negative 1 times negative 3 is 3 plus b. And I continue solving for b, which is the second step here. And I get 3 equals b. For the last step, rewrite the equation. We're just going to plug in m and b. So y equals, slope was -1, x plus 3. Again, it's not really necessary to write this -1. So it's really better if my answer is y equals -x plus 3. This example is very similar, so given slope and a point, we're going to write the equation of a line that passes through 6, -5, has a slope of -3/2. Again, this information gives me x, y, and m, and I'm going to start by plugging those in. So y is -5, m is -3/2, x is 6, plus b. When I multiply -3/2 times 6, it's easiest to rewrite them both as fractions. When you multiply fractions, you're going to multiply the numerators together and the denominators together. So when I finish multiplying, I would have -3 times 6 is -18, 2 times 1 is 2, -18 divided by 2 is -9. So this is -5 equals -9 plus b. If I continue solving for b, I would add 9 to both sides, so I get 4 equals b. And then if you remember from our previous example, the last step is to rewrite and just plug in slope and the y-intercept. So y equals -3/2 x plus 4. This is the last example of given slope and a point. So it says write the equation of a line that passes through the point 3, -3 and has a slope of 0. So I would write out my equation. I plug in y, m, and x. I start solving for b. I find out -3 is b. I rewrite, only plugging in my slope and my y-intercept. Remember, I don't really need to write 0x, so y equals -3. If you remember from earlier when we were talking about 0 slope, if I see 0 slope, I know that the line is going to be a horizontal line, which has an equation of y equals a number. And so really the easiest thing to do is go to your point and look, what number is y? Y is -3, and right away you would know the answer to this is y equals -3 without actually doing any of this work. This next example is writing an equation if we're given 2 points. So this time I have an equation of a line that passes through the points -1, 3, and 4, -2. So this time, I am no longer given the slope, so I need to do that first. Remember, slope formula is y2 minus y1 over x2 minus x1. So first thing I want to do is label these points x1, y1, x2, y2. Then I'm going to plug into the slope formula. So -2 minus 3, 4 minus -1, -2 minus 3 is -5, 4 minus -1 is really like adding, so 4 plus 1 is 5, -5 divided by 5 is -1, so my slope is -1. The second thing I want to do is pick one of my 2 points. It doesn't matter which point you choose. I'm going to choose -1, 3. And then I'm going to plug all this in. So now I have x, y, and m. So y is 3 equals m is -1, x is -1, plus b. Now I'm going to solve for b. So 3 equals -1 times -1 is 1. Subtract 1 from both sides. 2 equals b. Very last step, rewrite. So we're going to plug in m and b this time. So y equals -1x plus 2. Again, we don't really have to write the negative 1. So this is actually better written as y equals negative x plus 2. Next, we're going to focus on vertical and horizontal lines. So vertical lines always have the equation x equals a number, and they have an undefined slope. Horizontal lines always have the equation y equals a number, and they have 0 slope. For our first example, it says write the equation of a line with undefined slope that passes through the point 4, negative 9. If you think about this in terms of a graph, I would have 4, negative 9. That's this point here. I know that undefined slope means it's a vertical line, so that would be here. We know vertical lines are always x equals, and my x value is 4, so x equals 4. You don't have to draw a graph, it was just showing you graphically that's what it would look like. The next one is write the equation of a line with a slope of 0 that passes through the point 2, 14. So we know 0 means horizontal line. The equation is y equals a number. If you look at your ordered pair, the y value is 14. So for this equation, y equals 14. Our last two examples are parallel or perpendicular to a specific line. So this example says write the equation of a line that passes through the point 1, 7 and is perpendicular to the line x plus 6y equals 42. The first thing I need to do is rewrite the original equation in slope-intercept form if needed. So if you look at this equation, it's definitely not in slope-intercept form. Remember, slope-intercept form looks like y equals mx plus b. The y variable is always isolated, so that's my goal. So first thing I would do to start isolating y is subtract x from both sides. I cannot combine 42 and x because they're not like terms. Then I would divide each term by 6. So I have y equals 7 minus, it's best to just leave this as a fraction since it will be our slope, so 1/6 x. If I want to rewrite so that it's truly in slope-intercept form, I would just switch those terms around. Step 2 is identify the original slope. In this case, it's negative 1/6. Then we need to determine our new slope. So if we recall, our original example said perpendicular. So perpendicular means they are opposite reciprocals. So I'm going to flip this upside down and switch the sign. So if I flip our original slope, I'll have negative 6 over 1. When I switch the sign, it becomes positive. So really, my new slope is positive 6. Once I get my new slope, I no longer am interested in the old slope. I'm also not interested in the equation that they gave me. Remember they say through the point 1, 7. So now I have 1, 7, which gives me x and y, and I have my new slope of 6. With that information, this is exactly like our previous examples. So I plug all of that into y equals mx plus b, so 7 equals 6 times 1 plus b, and I start solving for b. b equals 1, and once I have that, I plug in my new slope and my new y-intercept. So y equals 6x plus 1. For the last example, it says write the equation of a line that passes through the point negative 5, 7 and is parallel to the line x plus 5y equals 10. First thing I want to do is rewrite the given equation so that it's in slope-intercept form. So I start by subtracting x from both sides. I divide each term by 5. Remember, leaving this as a fraction so that it's easier to identify my slope. When I look at this equation, my slope is negative 1/5. Then I want to identify my new slope. So if I revisit the example, it says parallel. So parallel slopes are going to be the exact same. So my new slope will also be negative 1/5. Then I take my point, which gives me xy, and my new slope, and I plug those in. So 7 equals negative 1/5 times negative 5 plus b. Remember, when you multiply fractions, it's negative 1/5 times negative 5 over 1. You multiply the numerators and the denominators. So I would get negative 1 times negative 5 is 5. 5 times 1 is 5. Slope is, this will really just simplify to be 1. So 7 equals 1 plus b. Subtract 1 from both sides. 6 equals b. Then rewrite. So y equals negative 1/5 x plus 6.